Hello guys, I am going to tell you about audio sound in multimedia. In physics, sound is a vibration that propagates as the acoustic wave through a transmission medium such as a gas, liquid, or solid. In human physiology and psychology, sound is the reception of such waves and their perception by the brain. Only acoustic waves that have frequencies lying between about 20 Hz and 20 Hz. The audio frequency range elicit and auditory percept in the human in air at atmospheric pressure. These represent sound waves with wavelengths of 17 meters 56 feet to 1.7 centimeters to 0.67 in sound waves about 20 kHz are known as ultrasound and are not audible to humans. Sound waves below 20 Hz are known as infrasound. Different animal species have varying hearing ranges. Acoustics is the interdisciplinary science that deals with the study of mechanical waves in gases, liquids, and solids, including vibration, sound, ultrasound, and infrasound. A scientist who works in the field of acoustics is an acoustician, while someone working in the field of acoustical engineering may be called an acoustical engineer. An audio engineer, on the other hand, is concerned with the recording, manipulating, mixing, and reproduction of sound. Applications of acoustics are found in almost all aspects of modern society. Disciplines include aeroacoustics, audio signal processing, architectural acoustics, bioacoustics, electroacoustics, environmental noise, musical acoustics, noise control, psychoacoustics, speech, ultrasound, underwater acoustics, and vibration. Sound is defined as oscillation is in pressure, stress, particle displacements, particle velocity, elastic or viscous, are the superposition of such propagated oscillation. Auditory sensation evoked by the oscillation described in sound can be viewed as a wave motion in air or other elastic media. In this case, sound is a stimulus. Sound can also be viewed as a excitation of the hearing mechanism that results in the perception of sound. In this case, sound is a sensation. Experiment using two turning forks oscillating usually at the same frequency. One of the forks is being hit with a rubberized mallet. Although only the first turning fork has been hit, the second fork is visibly excited due to the oscillation caused by the periodic change in the pressure and density of the air by hitting the other fork, creating an acoustic resonance between the fork. However, if we place a piece of metal on a prong, we see that the effect depends and the excitation become less and less pronounced as renounced isn't achieved as effectively.